next example. Just starting back here to this magnitude. There's two ways of writing the magnitude. You could use the symbol V, magnitude with the two vertical strokes like the absolute value symbol, or that could also be called, in this case, R, because we said R is the magnitude, didn't we? So in other words, to get R we have to go x squared plus y squared. So returning to the problem, to get R, because we got to convert this to polar form, which is R theta, we go negative 10 squared plus 16 squared and take the square root. So calculating that, we get approximately 18.87. Now we need to find theta. So above it says tan theta equals y over x. From your Year 9 trigonometry, you know that to get theta we have to take the inverse tan of y over x. So we apply that now. Inverse tan, make sure your calculator is in degrees mode. 16 over negative 10. That equals negative 58 degrees. Now it's important to pause and draw it at this point for these sort of questions. If we think about the Cartesian or component form, negative 10, 6 would be basically 10 units to the left and 16 up, and we would have basically a vector like this. Now remember, in polar form we have to consider the angle right the way around. So what does the negative 58 here mean? This is a little bit tricky at first to interpret. Well, because 58 degrees is acute and negative means that it's going to go clockwise, the only conclusion we can come to is that it's actually 58 degrees going this way from here. So what you would do to find the true angle or the true direction, theta equals 180 degrees minus 58, because the whole way around from 0 through to the other end of the x-axis is 180, and then we just saw it back up by 58, so we go 180 take 58, and that's 122 degrees. So the final result in polar form is 18.8, 122 degrees. Example 3, change the following to component form, find the result and change back to polar form. So we have two vectors, one minus another. So we have first vector minus the second vector. We could do this in component and Cartesian form easily. However, until you learn in math methods what's called the sine rule and the cosine rule, which is not to be confused with the sine ratio and cosine ratio, you have to take this longer-winded approach. When you learn the sine rule and the cosine rule, you'll be able to use a quicker approach than this. So how do we subtract vectors in this form? We have to convert them and then do the subtraction, then convert them back. Let's have a look. If you look at the video and then pause it, you'll see it's the same sort of calculations as just above. So we convert the first vector. Pause to have a look. For the second vector in polar form, we use the same method to convert to component form, r cos theta and r sin theta. Pause to have a look. We know from earlier work to subtract vectors in component or Cartesian form, we subtract corresponding components. We see that there, so pause to take a look. Then basically we do the calculations and we've got a result. The next step is to convert back to polar form. Converting back, we've got to find r, so the magnitude x squared plus y squared, so we have 7.62 squared plus 5.3 5.36 squared. Once we take the square root, we've got 9.316. So now it is time to find theta, the direction, inverse tan of y on x. So you have the inverse tan of 5.36 over 7.62. To two decimal places, that comes out to be 35.12 degrees, or about 35 degrees. The final result is 9.32 and 35 degrees in polar form. So out of the three examples, this was by far the most demanding. Once you learn some other rules and math methods, we'll be able to use a shorter version to do such things. Time to try some trig.